Hi there, math lovers, and welcome to another Math Olympiad training problem from the set of our Math Olympiad training problems of 2025. The problem that we have selected for today is a very simple equation, but with a very mindful solution, which might be helpful when you are considering to solve equations in rather unorthodox ways. So the problem for today is find all natural numbers m and n such that 3m plus 2 is equal to m squared. If you have any alternative solution, please pause the video and write it down in the comments. If no, let's take a look at the solution together. So what we are asked to do is to find all natural numbers m and n such that 3m plus 2 is equal to m squared. In other words, we can rephrase that the problem requires to find all perfect square numbers m squared such that when they are divided by 3, they give a remainder of 2. So in order to solve this problem, we will not get into, let's say, classical equation solving techniques, but we will take a look more, let's say, at another way of solution. So we know that all natural numbers can be expressed in the form m is equal to 3k, 3k plus 1 or 3k plus 2, with k part of the set of natural numbers including 0. So this is the only possible manners you can express a number with base 3, and of course this means that the number can give a remainder of 0, 1 or 2 when divided by 3. Now we will see how our equation plays out in these three cases. So when m is equal to 3k, to 3k plus 1 or to 3k plus 2. So we begin our study with a case when m is equal to 3k, with k from the set of natural numbers including 0. So m squared will be equal to 3k squared, will be equal to 9k squared, or 3 times k squared. This means that the remainder of m squared when it is divided by 3, it is equal to 0. So in this case, there will be no solution for our given equation. In the case number 2, where m is equal to 3k plus 1, we will have that m squared is equal to 3k plus 1 all squared, 9k squared plus 6k plus 1, or we factorize 3 on these two terms, and we will have that 3 times 3k squared plus 2k plus 1. This means that when m squared, which is of this form right now, is divided by 3, the remainder is equal to 1. So there are, even in this case, when m is of the form 3k plus 1, there are no solution for the equation m squared is equal to 3m plus 2. And finally, when m is equal to 3k plus 2, we do the same operations. M squared is equal to 3k plus 2 all squared, equal to 9k squared plus 12k plus 4. For these two terms, we factorize 3, and we have that 3 times 3k squared plus 4k plus 1 plus 1. Even in this case, we see that the remainder of m squared divided by 3 in this case is equal to 1. So it is not equal to 2 in order for these two left-hand side and right-hand side to be equal. So in all three cases that we took into consideration, the remainder of m in the first case when divided by 3 is 0, in the second case is 1, in the third case is 1, and is never equal to 2. So this means that we can finally say that there are no natural numbers m and n such that 3n plus 2 is equal to m squared. As always, if you like this problem, please leave a like, a comment, and a subscription if you feel like so you can be updated with other problems that we will upload on this channel. Up to then, thank you for your time and see you in our videos. Bye.